Thanks for coming. My name's Glenn Weeb. I'm a senior solution architect with GridGain, and I'll be presenting today with Mike Thiele.
And hi, I'm Mike Thiele Venkatakrishnan from IBM, and I work on our Z mainframe environments. Okay.
So I think let's just kick in.
Yep. Okay. So we're going to talk about two different aspects of Apache Ignite on Z and leveraging Ignite with mainframes. And the first is incorporating Ignite as part of a compute grid on the mainframe environment, and we'll talk about why that's relevant. And then the second part, we'll talk specifically about integration with Apache Spark and go through a use case and demo as well. So overall, from the perspective of what the mainframe is used for in today's world, many of our banking clients and FSS clients, investors, et cetera, use the IBM mainframe to run their core business operations. And in many cases, these environments, although performing extremely well, have not been modernized for multiple decades, right? And so any environment that hasn't been modernized in terms of the applications that runs on them will eventually need some transformation, and that's certainly true in today's marketplace with the challenges that our banks are facing, and certainly with Z. They do get value when they do transform to digital capabilities in terms of a return on investment and how much they can actually get for their investment, but it is a risky journey. So as we look at what various industries and industry organizations have done, particularly in banking, there's been an attempt to try to structure the architecture of banking, core banking capabilities. And one of the organizations in this area that's been very prominent is the Banking Industry Architecture Network, or BIAN. They've created, and this is a very simplified view of what they've created, but they've created an environment where you have core systems of record that are shown on the bottom layer here. That includes things like your transaction processing, mortgages, loans, et cetera, followed by a layer that has more of the digital agility capabilities like marketing, sales, servicing. And then, of course, at the top, there's the channel-oriented layers that deal with how a consumer orients themselves with the bank. The value of this is a more open architecture, a fabric that's connected via microservices interfaces, providing more agility to move capabilities around based on best fit, right? And the idea is to be able to do that, to do that transformation, get the agility with minimizing your operational risks and your liabilities at the same time. So as we look at each of these layers, why we are focusing today on our discussion around the mainframe, or IBM Z as it's called, is that many of our financial institutions run that bottom layer, that systems of record, on IBM mainframes today, and do so because of the performance, the throughput, the availability they get, and overall the HA and DR capabilities that we have, and they are all regulated industries. So some of the key requirements for that bottom layer as we dig into it is to ensure that as the transformation's going on, there's no negative disruption. Ensure that we're able to identify the right modular components in that system of record to interact with the agility layers. Make sure that the institutions can deploy new services quickly, and enable capabilities like real-time insights. So we're introducing something in partnership with GridGain, as well as another partner that we have for IBM Z called the Z Compute Grid. And our partners in this regard are GridGain as well as Rocket Software. This is one of the blueprints that we're focusing on for our work with clients to help transform and modernize their environments. And it's an in-memory resident compute grid. That means it's data plus processing, not just raw data. And it's really focused on a tight integration with the systems of record and making that efficient, but providing the right sets of interfaces upward as we move through the various agility layers. Initially, the coherency or the consistency of the data from the OLTP online environments into the compute grid may be a few minutes, but we are on a roadmap to a full coherency if that's what the grid instance needs. We can actually have context-specific instances, and we'll talk a little bit more about those details. And we can, of course, span each of those instances across multiple LPARs or server environments for purposes of HA. The other thing I want to mention is that we are focused on some specific use cases for financial services. There are data formats such as ACH for payment processing, ISO 20022 for SWIFT messages, 8583 for credit card formats. And we're actually building those into part of the data abstraction and virtualization layers so that we're able to read the raw data with context, and so that it doesn't have to be formatted into appropriate through appropriate mechanisms for consumption by the grid consumers. So in this picture, you'll see that we've essentially been able to, just get my pointer ready here, incorporate the Z compute grid with the system of record functionality. And the systems of record generate data across a wide variety of environments, and these are, these are Z-based environments, and they're specific to Z. But the interesting thing about them, of course, is that they don't have standard interfaces of JDBC and ODBC. Some of them do. Many of them don't. And then, of course, the requirement is that the compute grid can interact with that data without impacting the performance of the system of record. So that's a very critical requirement that we hear from all of our clients, right? So this compute grid is really a combination of in-memory Ignite instances combined with an advanced data virtualization abstraction layer that knows how to read all of this data, does so in a way that's efficient, performant, in parallel without impacting this OLTP. And we incorporate the financial data templates there as well. So as the data is being read, if they are aligned to any of those particular formats, it'll have context once it's read into grid instances. The grid instances can vary depending upon the use of those instances by the modular business functions. And in this slide, you can see that, as an example, we might have one instance that's focused on transaction activity and analytics by client or product, another one that is focused on handling real-time inquiries and spiky workloads that you might want to offload from a system of record. The Ignite compute capabilities can span, of course, across all of that set of grid instances. We can have Ignite storage. We can also have in-memory capabilities and key value caches. The connectivity from these grid instances to the data it can be configured, right? So one particular instance might rely on 2 different data sources. One particular data source might be used, in this case, by 3 different grid instances. That's all configurable, right? And the access, we've shown the access directly going through, but if that data happens to be in an Ignite persisted environment, we can leverage that as well. Okay. And this is just a quick example of one of the industry mappings that I referred to specifically for ACH. There's a UI capability that helps our clients to associate a given data mapping that we provide with a given data source. And this is an example, I think, of ACH and payment mappings. And we're able to add additional mappings and build that out as we move forward if we need to. Okay. So that's the section that we wanted to discuss around the compute grid. It has a lot of different use cases. It can apply cross-industry. We're focusing a lot on the financial sector because many of our clients are in that space, but certainly almost any industry can apply. I think we want to talk next about how we can leverage Ignite with Apache Spark, and Spark that's also integrated on systems of record for efficient analytics of all kinds. So today, we're talking about Z and mainframes, and one of the questions is, well, why would we talk about that from an analytics perspective? But when you look at what the mainframe is used for in today's world, it's heavily penetrated into the global banks. There are billions of transactions per day that run through Z on a daily basis, everything from card processing to various kinds of payments to insurance claims, tax returns, et cetera. Every part of your life that you can think of, there are relevance, relevance points for why the data that is generated by these systems of record is so critical. It's high-value data. Often the data is unique for that particular client, so it's their advantage, it's their intellectual property. And so analyzing it effectively and efficiently makes a lot of sense. And the degree to which they can do that around the notion of data gravity and transaction gravity in terms of where the data is sourced gives them an advantage. Now, having said that, today many of the capabilities around analytics actually pull data off of source systems wherever they are, including the mainframe, pull them into one or more data lakes, and then run after-the-fact analytics. And in some regards, that's true because we haven't always had the capabilities to incorporate analytic processing with OLTP or systems of record. But we do. We do now. And so we've actually been focused from an IBM perspective on creating what we call an analytics runtime based on open source technologies. The product, it's called Open Data Analytics for ZOS. We focused on open source for analytics because the rate and pace of innovation in open source for analytics far outdoes really what any vendor is capable of. So we focused on enabling Apache Spark, Python, Anaconda. Actually, we now have R support as well. Now, enabling that on Z is really not enough because they can run anywhere, right? But the key is to enable those analytic runtimes and have them integrate with a unique optimized data layer that knows how to get access to a wide variety of data and can provide that abstraction so that if you write a Spark application on Z or not on Z, it looks exactly the same. There's just a different driver that's provided, regardless of if you're accessing VSAM files generated by a COBOL program, DB2, or an Oracle or Teradata off platform. It should look the same. Okay? And as part of the result sets of the open data analytics capability, we can actually persist those in an Ignite environment, and that is something that Glenn's going to talk you through in more detail.
Can I ask a quick question about your data virtualization layer?
Sure.
Going back a few slides.
Yep.
Are you actually pulling information from IMS into the grid, or are you providing kind of a federated query layer, leaving the data there, and then just kind of pulling up a representation? So I was just curious how you were using the term data virtualization.
Yeah. So in this case, the data virtualization has a SQL engine. So if you wanted to push a federated SQL query into that, it can federate across, say, IMS VSAM and your Teradata warehouse, and it will federate that query, pull the results back together, populate the result sets into the grid instance. So it's not pulling all of your IMS into the grid instance because it just wouldn't be viable to do that, right?
Yeah, so I think the answer there was yes, you can do both, right? You can push through, or you can stay, as this diagram shows. You can stay at the cache, or you can continue on down and read through, should you want to, okay? Right, so the fantastic thing about partnering with IBM is that we can bring the tools that modern application and analysts are using today, the Anacondas, Pythons, Jupyter Notebooks of the world, and provide it to where the data is. I think that's what my big point was. So in doing so, Ignite can run directly on the Z platform. All the things that make mainframes unique are some of those advantages that you get around the high availability and throughput and so forth. But there are some costs involved, both from how people do development today, and we don't necessarily want them, or they don't want to necessarily pull up a green screen mainframe terminal to do their modern REPL-based analytics. That's not what everyone is doing these days. Maybe some of you have done that, and I'll show a demo for those of you who want to continue doing that, but that's not everyone. So one of the things that we've done in allowing Ignite to run natively on Z is handle the differences in the platform. So the endianness of the chip is handled. The byte encoding is handled. So when you use Ignite on Z, it looks exactly the same. Unless you want to pull up a terminal emulator that's TN327, and I'll show you that in a second. So if you look at what does Ignite in this Z environment look like, if you have your Z application at the top there, you're building that with a Spark, as an example, a Spark session, and doing stuff with Spark RDDs, data frames that go through this optimized data layer to your existing MDS, Rocket software-based access to vSAM, IMS, all those kinds of data sources. So that's great that you're able to do that. Now, when you enhance that with the ability to have low latency Ignite in-memory caches, you add an extra advantage, an element of advantage there. So those Ignite result stores that are cached in memory do so in a way that is both transaction analytics supportive. It gives you Ansi SQL support or key value API access. We can supply that to a set of open APIs, REST-based, JDBC, ODBC, SQL-based, Python, R, Spark, etc. And when you use Spark, you also have some extra advantages with the Ignite-based platform. You have the low latency data storage that you can retrieve. You have inter-step support, so you can execute multiple Spark applications and still have your cache exist from one step to the other. Right? So I think of that as sort of the horizontal scalability of a Spark application. It doesn't die when the Spark application completes. It continues on. Also, you get within multiple Spark applications, they can see each other if you want them to be. So there's a whole bunch of advantages in the Spark application topology. And with Spark SQL, you have limitations in what you can do. With Ignite SQL, you have the ability to have indexing. You have the ability to supply multi-field indexes to your data. So your Spark SQL can be accelerated over what Spark SQL can do. And also with the SQL in Ignite, you also have update, insert, update, write support, whereas you don't have that with the immutable Spark SQL. So then when you put those things together, a Z application can have enhanced capabilities that can use your Spark and Ignite superset. You can have analytic and transactional processing. You can use compute elements, not just data access. You can do pre and post Spark execution. So if you need some DML ahead of time, create some tables. If you need to do some post SQL, like you want to do an aggregate calculation and update your data set, you don't have to create a data frame for that. You can just issue an update. Boom, you're done. Right? So there's a huge advantage to having a superset of Spark plus Ignite in that runtime on platform. Looking at one of the clients that we're working with right now, was just came from their site last week. This is the solution that they're using. They have their customer banking records are being updated in a CICS KICS transaction. At the end of the transaction, they write the data out and store it into Ignite. So Ignite is real time. It has the latest and greatest value in your bank accounts, so they know all those values. But it also has a whole bunch of other data that allows them to do analytics now, real-time analytics in their data at low latency, at low cost. All of the Ignite processing is zip enabled because it's running in a JVM. So all of these things are done in zip. They're able to combine data that is in MDS, local vSAM, IMS, CICS-based data sources, as well as within Ignite. And they're able to provide an experience to their analysts, their business community, that they haven't been able to in past. In past, it's been very siloed. Here's the mainframe folks, here's the business users, analysts, people who don't, ne'er the twain shall meet. Now they do meet because they can use the same tools. And here's a set of some of the tools. if you look at some of the modern analyst tool belts, this is kind of a good cross-section of the tool set that modern analysts are using. So if we look at our compute grid on the bottom there, how do these interact with them? So Postman is very common for your REST-based interface application development. So with Postman, you can come to a GridGain Apache Ignite running on Z and interact with your standard API, standard gets, standard puts, all the kinds of things that you'd expect to do, but also access SQL, key value, compute-based execution, as well as get topology management, admin, monitoring functions as well through a common interface. If you're in the more relational SQL-oriented world, dbeaver is a common tool that people would use. But really, if you're using Tableau or any other kind of JDBC, ODBC relational tool using standard SQL, you have those tools all available. So within dbeaver, this is what it might look like. And I'll give you a live demo of all three of these applications. But metadata, data access, read, write, all available to you. You don't need to know that it's Z platform at all. We have Ansi Sql Support, the ability to enhance SQL with custom functions. Custom functions provide you all the compute capability within the grid, data locality, all the kinds of speed and execution that you get there. You have ACID and atomic level transaction support, index retrieval, multi-index, multi-field index, search, all these kinds of features that we add to the relational interface when done within GridGain. And then finally, in the Jupyter Notebook, Anaconda, Python world, it looks like any other notebook out there. You use PyIgnite with PySpark, possibly also with PySpark, and you get full access to all the caches and tables, RDD, data frame support, persistent caches, et cetera, as I mentioned before. And again, taking advantage of the indexing that Spark doesn't give you. That's the end of the formal presentation. So now I'm going to go live. Are there any questions while I go live? Yeah.
Spark is written in Scala, and it's Java-based, and the mainframe has a full supported Java environment. So Spark Ignite actually worked, reasonably well out of the box. So we did have to do integration between those layers and the data virtualization piece in order for that data virtualization piece, which is not written in Java. It has to read all of those unique data sources and be able to represent them as Spark RDDs or to Ignite. But to an Ignite environment, it looks just like any other JDBC driver, right? Anaconda is a little bit different. Animal Python Anaconda did need porting because they're typically C and C++ based. So we've actually ported Python and about 250 of the Anaconda libraries natively onto the mainframe environment.
Yes, a lot of the magic came from IBM's support of the JVM environment, and we take advantage of that. You'll see when I pull up my TN3270 terminal emulator, because I thought that was the most popular environment here. Yeah, I got a couple people saying yes, no, they're joking. But no lie, this is all there. So if you want to do it through TN3070, yes, there's my Java application. It is running. It's all good to go. If, however, you're more comfortable in a traditional shell, this is the bash terminal within within Z. So we did take advantage both of the JVM support on Z, but also the fact that there's a full bash shell, so all of our scripts for starting and controlling and monitoring all support and work
And you're
there.
running live on the,
I am VPN'd in, so this is real, not Memorex. You see, I'm using all these old references. Let's just make sure that my connection is still there. Right, so I've got a Cisco VPN connection, 129.40.19.30. For those of you following along at home, that is the session. Okay, so if you don't like a command line interface, then GridGain supports a full web console. And so here you see a number of clusters, 3 clusters available, one of which just so happens to be running on the mainframe. My mouse is no longer working. So I believe this version here, 129.40.19.33, is the Instacart example. So as Maithili mentioned before, where we might have different nodes for a specific business application, this is a retail application. And if we look down in our web console, we see that we have a dozen so tables available and about 40 million rows loaded in here for demo purposes here. But again, no difference because this is Z or running on my laptop. They look the same and from a usage perspective. So the training that people need is completely transferable. If I'm running in a Jupyter notebook here, I can create my Instacart example here. I merely have to create a client connection or import the Ignite libraries, packages, make a connection to my mainframe, and at that point I can access the caches or tables and run select statements to pull out the data. If I am using a dbeaver environment, I can browse through my environment, look at metadata, look at my order products table, which is order line items, and look at the column types, and look at indexes, and do all the kinds of things, and note that I have a multi-column index supporting this particular table. And
I just want to comment, it would look the same in this regard, whether you were looking at the data from DB2, IMS, VSAM, or a federated query across all 3, right? So the results get returned back, and the interface that you're looking at here would remain the same.
Exactly. So I can run this query here and boom, get my data back, and notice that within my 4 million orders, I have most of my orders on Instacart come on Sunday, and not many people do grocery shopping on Thursday. They're out partying, apparently. I did not know that. That's a good thing to know. All right, so we've done Postman, we've done Web Console, we've done dbeaver. One last one, what was, then Jupyter Notebooks. I think I've done them all. I think that's it.
Yep.
So what I wanted to present to you was to show you that nothing's different. So if you are a mainframe person, nothing's different. You're able to do the work on your environment and support people who don't think anything's different because they're in their analytic environment, and those 2 environments can now work together. So if from a cost of getting your data environment to support an analytic application, you can now minimize the data movement by putting your analytic tools, the tools that people are used to using, in the right place, because it's right next to the data. It's right where the data gravity is. You don't have to do ETL if you don't want to. If the cost of that, as all of us who have dealt with integration know about, ETL, especially as you get more to real time, the costs of building and managing ETL, or data movement, is expensive. Here you can support your business community and analyst community with the tools that they expect on the platform that you know and love today. Questions? More terminal 3270 tricks. Question? Yeah.
Once it's all set up, accessing the data across all those databases, I'll trust you that it works. Great. How complex is it to configure in a particular database?
I can answer that. So let's say you've got, you're configured and authorized to access a set of DB2 tables. Adding in additional DB2 tables for you to access, there's a UI that says Studio, an Eclipse-based data studio that allows you to specify, point and click to which tables you want to virtualize and say virtualize these. Now, it does require the system administrator to have given you the authority to access those tables, right? So that's a step that is outside of the click and point. You can't get access to everything just because it can be sensitive data. The other thing I want to point out is that the sysadmin can actually create virtual table views of that data that can remove certain columns or obfuscate certain columns. So let's say he wants to give one analytic group all of the data, another analytic group all of the data minus the column that's got social security numbers because they're irrelevant for analytics. You can actually virtualize a table with that column gone and say, okay, you're authorized for this, right? And you can do whatever you want, but it doesn't have to match one for one with the original raw data. It could also be a blended view. So if what's more desirable for the organization to surface to their team of analytics and analytics folks and data scientists is a blended view across multiple sets of data, and do that aggregation and then surface that, you could do that as well. So there's a lot of flexibility. It's done through an Eclipse-based interface, right? So you're not green screening it. You can if you want to, but
It's black.
black screening it. So there is a lot of flexibility, right? But we also do make sure that the authorizations are handled. So it's not wide open to everybody because the mainframe's data sources are generally protected and sensitive as they should be. The other thing I wanted to point out is that we put in special capabilities within that data layer to access data not necessarily through the same interfaces that the OLTP is using in order to update the data, right? And that's how we minimize or eliminate the impact to the running systems for accessing that data as well.
I was just going to go create some tables on the mainframe right now. I just thought that would be interesting. So if you happen to be wanting to create a sandbox and do something of interest, we could create a table. Let me create a new query in my notebook here. I thought I copied that. Let me try that one more time. If I run just those and I pick the appropriate cluster, which I believe was 904, 90 something. Right, so 90D5. So if I run that query on that thing and execute this, oops. Now when I go over to my monitoring dashboard, I actually see that I have created an additional table here that I've loaded 3 records into. The point I'm making there is that if those of you who saw Nikita's presentation at yesterday, there is a whole concern around the complexity and difficulty in doing some of this stuff. And many people who come to GridGain come to it from a developer perspective. And so they're building Java code that might look like something like this. So you have to be comfortable in this space and building, models of your objects and so forth. However, there's a whole community that just wants to create a table and use DDL, create a table, insert some data, and play around with it, right? So even though that's running on the mainframe, you can still do that, right? Within the privileges, we've set up for you. Okay, so again, power to the users, power of the data in the platform that is generating the data. Any other questions? Well, we've given you 8.5 minutes back in your day. Go use that well. Thank you.
Thanks.